Alright, so we're going to go over some things that you need to remember for our next unit. And the first task on D6 is, can you complete the square? So hopefully you remember that we have things called perfect trinomials, and they take on the form of a squared plus 2ab plus b squared, or it could be a squared minus 2ab plus b squared. The good thing about these perfect square trinomials is that when you factor them, they look like a plus b quantity squared, or they look like a minus b quantity squared. Of course, not all trinomials are in this form, but we have a process called completing the square where we can have it take on this form if we have a trinomial equation. So, looking at your D6 assignment, number one, they kind of show you the steps. Maybe it's not coming back to you, so I'm going to do number two with you guys as an example, and it's x squared minus 14 x minus 1 equals 0. Because I have an equal sign, I do have the option of completing the square, because we can use the property, the addition of equality property, meaning if I add something to both sides of the equation, I still have an equal equation. So right now, my trinomial is not a perfect square trinomial. And remember that we did have a way to check. What you did was you took half of your b term and square it. It should be what your c term is. And it's not, right? So what we're going to do is we're going to shift our c term over by adding 1 on both sides so that we can make room for a new c term that would work. Okay, the sign that goes here should match your, should always be a plus sign. Because in either case, it says plus some quantity squared. All right, but the sign that goes in my factored form should match my b term. So if it's negative b term here, then in my factored form, that sign should match. So this is the form we're looking for. We want it to be able to factor to x minus something quantity squared equals 1 plus something. So now we just need to figure out what these somethings are. So to get that, we're going to take half of our b term, which is negative 7, and that's what goes here. Then we're going to square it, and that number is the number I need to add to both sides of the equation. Okay, so I'm going to do another one with you guys. So this is number 4, and we're given x squared plus 7x plus 13 equals 0. So when you're looking at this and you're checking to see if this is a perfect square trinomial, remember you're checking to see if your b term, if I take half of it and square it, would it give me my c term? And it does not. So what we're going to do is we're going to change the c term so that it is. So we're going to need to make room for that. So we're going to subtract 13, x squared plus 7x plus something equals negative 13 plus something. And again, remember this is always a plus sign here because in either form, it's always a plus b squared. Okay? And remember the sign that goes in my parentheses should match the same sign as my b term. Okay, to get our numbers that goes here and here, first we're going to have to half it. So 7 divided by 2 is 7 halves. Then, to get the number that I'm adding to each side, we're going to square it. So 7 squared is 49, and 2 squared is 4. So I need to add 49 fourths to each side. All right, so this, to simplify, I'm going to have to find the common denominator. So 4 times negative 13 plus 49 over 4. And that gives me negative 3/4. All right, the next skill on your D6 worksheet they need you guys to remember how to do is from geometry. So the next skill is finding the distance between a pair of points. The distance formula is, we'll call it the distance x. Well, actually, let's call it d. D for distance is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared, like that. But the distance formula is actually derived from Pythagorean theorem. Remember how c is equal to the square root of a squared plus b squared, where the difference of my x-coordinate is kind of like your a leg of the triangle, and the difference of your y-coordinates is the b length of your triangle. So I'm going to be kind of using this method instead, because it's easier to do, I think, than that. So let's do one together, like number 11 off your worksheet. We're trying to find the distance between negative 2, 1 and 5, 3. Okay, so if you want to use the distance formula, you can. I'm going to show you another method based on Pythagorean theorem. So the a value is the difference of your x terms. So if I'm starting at negative 2 on the x-axis and I'm traveling to 5, I've traveled 7 spaces. So my a value is 7. So that's the a squared part. Okay, and then to get the b part, we're looking at what has happened on my y values. So I'm starting. Okay, so actually we're starting at negative 1. I copied that point wrong. So we're starting at negative 1 and we're traveling to 3 on the y-axis. So that's 4 spots, 4 units that we've moved. So we're going to write 4 squared for the b leg of my triangle. All right, from there what we're going to do is evaluate each of those. So it's 49 and 16 underneath the radical. And then 49 plus 16 is 65. So that's what goes under the radical here. And then at this point, what you would do is see if radical 65 reduces, if we can simplify this radical, and it does not reduce to any square factors. So we're going to leave our answer as the square root of 65. All right, the next skill that you need to be able to do is also from the distance formula. For question 13 and 14, it says find the value of p so that each pair of points is 25 units apart. So this is different because they actually give you distance and you have to find a missing part of the coordinate within using the distance formula. All right, so I'm going to work out number 13 with you guys as your example. So number 13 has p, 3 and 8, 27, and the distance between them is 25 units. All right, so going back to our distance formula, right? Distance equals square root of, right? We have this. We're going to substitute all the values that we know. So I know d is 25, right? And so we have p minus 8 and 3 minus 27. 625 equals, I'm going to leave p minus 8 quantity squared the way it is. We'll talk about why we're not going to expand that in just a second. Plus 3 minus 27 is a number, right? That number is negative 24, and when I square that number, it becomes 576. All right, so I'm trying to solve for p, and I don't want to make it, there's more than one way to do this, but I don't want to overcomplicate it and create more work for myself. So the next thing I'm going to do is I'm going to get rid of the square root sign here by squaring each side. So 625 equals p minus 8 quantity squared plus 576. Right from there, I'm going to subtract the 576. Which gives me 49. So 49 equals p minus 8 quantity squared. Okay, what you could do, this is where you can branch off two different ways. You can actually expand this out, move the 49 over, and solve by factoring. Or what we can do is I'm going to take the square root on both sides. And remember, when you take the square root of 49, I get plus or minus 7. And to me, this way is a little bit easier because then I can skip factoring. So now I'm going to solve with two different equations. One is going to be a positive, and then I also have to solve it as if negative 7 was the answer. So p can be 15, or p can be 1. And I do expect two answers because it was a quadratic. All right, the next skill set on your review sheet is talking about find the midpoint between a pair of points. Remember, the midpoint in geometry is a point that is equidistant from endpoints. Since we have two endpoints and I want to find the center of those, it's the exact same thing as finding the average. We do have a formal formula for that. Remember, capital M is the midpoint. What you're going to do is you're going to take your x1 value and x2 value, divide it by 2 to get the x part of your coordinate for midpoint. And then to get the y part, we do the same thing with our y values. But in essence, it's an average. So that's the way you can think about that. And then the last thing that you should be able to do is another geometry concept, is find the missing endpoint. To find the missing endpoint, there are two ways to think about it. I'm going to work out your number 18 with you guys and kind of talk to you about both ways to do it. So they give you point A is 5, negative 16, and your midpoint is negative 13, 2. So what we could do is solve it algebraically by substituting into the formula. So my midpoint x value is negative 13. The x values are coming from this. So I can set up negative 13 equals x1, which is 5. x2 is, I don't know, divided by 2. And you can solve for the x part of your missing coordinate, and they're telling us that we're going to call it b. So you could solve for x, and that value goes here. You can do a similar thing with your y values. Whatever that is, you're going to put for the y part of your coordinate. A shortcut to think about it is this. Shortcut is the equidistance part. So if I know that I'm equidistant, the traveling steps I take from 5 to negative 13 has to be the same kind of traveling steps I take to get to the other endpoint. So from 5 to negative 13, I have traveled negative 18 spaces. So that means I have to travel another negative 18 spaces. So negative 13 and negative 18 makes negative 31. And then same thing with my y values. Traveling this way from negative 16 to 2, I've traveled positive 18. So I have to travel positive 18 again for my y values and end up at 20.